Hello, I'm Anna Mackay, and this video is on the mean and standard deviation of a binomial distribution. So what does that all mean? Let's think about some examples that we are familiar with. If you had a coin, what's the probability of you tossing a tail? Well, we know that you've got a 1 in 2 chance of that happening. So if we tossed that coin 50 times, how many tails would we expect? Now there's a bit of common sense that just kicks in here. So hopefully you already know what the answer is going to be. A good way to start setting up these questions is identifying our n and our p. So n is the number of trials, so in this case 50 times, so we'll write 50 here. And p is the probability of a success, and a success in this case is a tail, so we've got a 1 in 2 chance. So how many tails would we expect? Well, you might be thinking half. So how did you do that? Technically what you did is you multiplied 50 by a half, or n times p. So that's technically what we're doing. So let's write that out. np is equal to 50 times by a half, and therefore we'd get 25 tails. So n times p, that's what we would expect. Another one, if we had a die, what's the probability of rolling a 4? Well, there's 6 sides to a die, so 1 in 6. Now, if we rolled that die 30 times, how many 4s would we expect then? So let's identify our n, our number of trials, so 30. So n is equal to 30, and the probability of that success, the success of a 4, is 1 out of 6. So if you rolled that die 30 times, how many 4s might you expect? Well, a 1/6 of the time, so 5 4s. And the way you did that is you multiplied 30 by 1/6. So to work out our expected value in that sense, which connects to other parts of the topic that we've talked about in the past, we multiply n by p to get 5 4s. That's how many we would expect. And that expected value is the mean of a binomial distribution. So our technical definition here is mean, mu, is equal to np, or n times p. So summarising that in the technical definition, if x is a random variable, which is binomial, so a success or a failure, with parameters n and p, and this notation here, so that's a way of writing what the binomial distribution is. So B for binomial, because in another section we'll have n for normal, n, number of trials, and p for the probability of them happening. And so here's our technical definition. The mean of that distribution is n times p. Our standard deviation is this, and variance, which is standard deviation squared. So just doing one example here. If we have a die and we roll it 12 times, and x is the number of 5s that could result, we need to state the mean and the standard deviation of x. So each time you come across a question like this, before you think too much about it, get into the habit of writing out your n and your p. So you've got something to refer back to. So rolling a die, that means a 1 in 6 chance of something happening. Now, another good habit to get into is either doing n and p or writing out the distribution. So we do x, and then that squiggly line, it's called a tilde. It's under the escape button on your keyboards if ever you need it. We write b for binomial, because as I said, in future we'll be dealing with the normal distribution, and then we would write an n there. And n and p, so that's in alphabetical order, n comes first, 12 and a 6th. So you would either write this one or this. Don't just write 12 and 1/6 on the page, make sure you write p is equal to and n is equal to, so that you've got a reference point. And an examiner, for when you come to the exam, will know what you're referring to. Okay, and then we need to write what our mean is. So mu is equal to n times p, and so we've got 12 times by a 6. The answer to that is 2. So we would expect 2 5s, and then the standard deviation, as you can see from the formula, I like to get into the habit of writing the formula out each time. So standard deviation, so that's sigma. So n is 12 times by our probability times by the complement of the probability. So 1 subtract a 6. So we're left with 5/6, square root of all that, and your answer is approximately 1.291. We tend to go to 3 decimal places or 3 significant figures. Somewhere in between there seems to be pretty standard. Okay, so that's the end of this video and the end of the discrete random variable series. If you liked it, give it a thumbs up and subscribe to the channel, and we'll see you in the next series. Thank you.